Well, next one, we'll turn to page 7. Okay, page 7 of your notes is talk about carboxylic acid or alkanoic acid. Now, you should emphasize or mention in your notes, okay, because I haven't put it here. The first properties or chemical reaction involved is acidic properties, okay? So this is the only chemical that can react with sodium carbonate or hydrogen carbonate to give colorless bubble. This is a very important test for the carboxylic acid, okay? So please highlight it and write it down in your notes, okay? This is a unique properties that other functional group cannot do so. Well, next one is esterification. Well, you should be familiar with that, okay? The carboxylic acid react with alcohol under corn sulfuric acid as a catalyst, okay, to speed up the reaction. And under high temperature, we use first. They will form ester and water, okay? Now, you can see here, I use or try to use some word to describe the ester. You will see it in examination so often. The first one is called fruity smell. It smells like fruit, okay? The second one they will use is pleasant smell. So next time when you see these terms in the exam questions, that means ester is formed or evolved, okay? So this is a very important hint. So you should highlight it, okay? So here is example. The carboxylic acid react with alcohol to form ester and water. So you can see the water actually comes from the OH contributed by the carboxylic acid and the H contributed by the alcohol, okay? Now, but we will talk about the reverse process first, okay? For the reverse process, okay, this is in page A of your notes, okay? Esterification, we have a reverse process. Reverse process means from ester and water will break down into carboxylic acid and alcohol. So we use the term called hydrolysis, okay? Hydrolysis. We have two types of hydrolysis, so you should pay attention because the product is so similar. The first one is called acidic hydrolysis, okay? The characteristic for acidic hydrolysis is reversible. So for example, ester here, with the acidic environment and heating, you break down into carboxylic acid and alcohol. Okay, no problem. But the point is, because the reaction is reversible, so we can see actually these are the reagent for forming ester. Okay, so you cannot get pure alcohol or pure carboxylic acid, or you may say the reaction is never complete. Okay, so we have alkaline hydrolysis, which is irreversible. So you can see this time we use alkaline medium, okay? And because in alkaline medium, the carboxylic acid will be neutralized to form salt, okay? Now, because this one is no longer the reactant, so they cannot turn back into ester. So this is a one-way reaction, or we can say this is 100% complete. But how can we obtain the carboxylic acid back? Well, the answer is very simple. After the first reaction, we add acid to the reaction mixture. In room condition, no heating is needed, okay? Because carboxylic acid are weak acid, they will seldom ionize, so they will combine, the salt will be combined with hydrogen ion to form the carboxylic acid back again. Because this is in room condition, no heating, so don't worry, they will not turn to ester again, okay? Okay, the second one is the other properties for carboxylic acid is they can be used to form amine. Okay, the process is a bit complicated. First of all, we need to use PCl3, and secondly, we use ammonia. So that means in your exam questions, you should include these two factors along, okay? Cannot miss either one, okay? They will form the amide. For the detail of the experiment, we will not discuss in the DSE level, so forget it, okay? So, similar to the acidification, we have a reverse process, okay, for the amide formation. We can actually break down the amide, okay? Now, before we discuss the hydrolysis, that means the breakdown process, so you should have a picture in your mind. Amide is more or less like carboxylic acid and ammonia, okay? Their reaction is more or less the same, okay? So once again, we have two types of hydrolysis, okay? The first one is called acidic hydrolysis. Now, the different point is, you can see here, we have carboxylic acid and ammonia, but if you think carefully, you can see that this one is acid and this one is base or alkaline, so that they should not appear at the same time, right? So take this as an example, even amide, okay? Even amide under acidic environment, okay? For the acidic environment, this one will be neutralized. This one will remain. So you can see the carboxylic acid remains, and the NH3, the ammonia, will be neutralized to form a salt. Okay. Now, in your notes, there's a very special term called alkyl ammonia salt. Well, this is a general name, okay? So if you feel uncomfortable, so you can just forget it and use the ammonium salt. It's okay. Well, for the alkaline hydrolysis, okay, the situation will be reversed. The acid will be neutralized to form a carboxylate, and ammonia remains. So this one will be neutralized to form a salt. So how can we get back the carboxylic acid? So easy, just like what you have done in the hydrolysis of ester. We use acid or give an acidic environment. It's okay, then you can obtain the carboxylic acid back.